Hello, good morning, good afternoon, good evening, wherever you are, and welcome to the stream. So, yeah, I'm not sure how many people we've got in at the moment, so maybe we'll just talk a little bit while people come in. But anyway, my name's Matt Hamilton. I'm a developer advocate at Protocol Labs, and so this is a stream that's just going to be talking about where we are with the Filecoin Ethereum Virtual Machine and give an example of deploying a contract using what we have so far. So the Filecoin Virtual Machine, I'll give you a bit of a rundown here. Just want to check is I don't know how many people are in the chat, but hopefully you can hear me. If somebody there can just let me know that things are all working okay, that would be good. So yeah. But the Filecoin Virtual Machine is, it's video buffering. Something's coming up here saying about low latency mode. Hopefully it's working okay. Just checking here. Everything looks okay. Anyway, Filecoin Virtual Machine. So Filecoin Virtual Machine, you can find out a bit more on fevm.filecoin.io. So I'll just pop that in the chat there. So this is the functionality that gives smart contracts on the Filecoin blockchain, right? So the Filecoin blockchain is all about storage, and the Filecoin Virtual Machine gives us a way to add programmability to that storage and to the storage contracts that are used to manage the storage. So there's two particular aspects to the Filecoin Virtual Machine. So the main bit is it uses WASM for a execution environment. WASM's used on a lot of other blockchains. The XRP Ledger, for example, uses WASM for smart contracts with hooks. And you have these kind of native, what are called native actors. So actors is the name for smart contracts in the Filecoin ecosystem. And we have these built-in system actors that are compiled from Rust down to WASM. So these are actors that are what were native functionality on the Filecoin network have been refactored into being actors and run on the virtual machine. So great. Jim, hello. Great to see Jim here. So the tutorial we're actually going through is a tutorial written by Jim. So yeah, all credit to Jim for writing this tutorial and being involved, obviously, in the development of FEM itself. So what we're doing is we're working through in this session a tutorial that he created. So the fact he's here, Jim, you can pull me up if I say anything wrong, or if I get anything wrong, or if anything breaks, then I'll at least you're here, which is cool. So thanks for coming along. So yeah, so as I was saying, the Filecoin Virtual Machine, we've got FEM, which is the WASM-based system, and there's various languages that can compile down to that. So Rust, there's also some assembly script, I believe, which maybe we'll cover in another session. But then also we have this EVM compatibility, right? And so we have the Filecoin Ethereum Virtual Machine. Now this is what's being developed at the moment, and there's a kind of a timeline for this that's being developed. Actually, I probably should have brought that up. Let me see if I can bring that up here. What was it? Incremental development. Incremental delivery plan. Yeah, I got it here. 1 second. Oh, we've got this incremental delivery plan here. So if anybody wants to have a look at this, I'll put that in the chat as well. So that's there. Everything's developed on the Filecoin project GitHub. But we've got this incremental delivery plan that we're working on for the Filecoin Ethereum Virtual Machine. So what I'm demoing today, we are partway through development. So this is not how things are going to be finally, but this is just a chance to kind of see what things look like at the moment and just see the progress. So we're doing this incremental delivery plan, and roughly about once a week, we're doing a deployment. The milestones are based on what's called the Moore's mineral hardness scale. So we've had talc, selenium. The latest release is copper, and then the one coming up is iron on that. So you can kind of follow along on there if you want to see how development's going. And we're working right the way up to the end. And by the end, you should be able to use standard Ethereum tooling for developing smart contract. So, you could deploy to Filecoin just the same way as you deploy to Ethereum. At the moment, one of the things we don't have is a fully functional RPC layer to allow you to interact with it. So the latest release, Copper, brought some of that functionality around. But in the meantime, Jim has created a tool that allows us to sign and deploy smart contracts, compiled smart contracts to the Filecoin Virtual Machine. So this is what we're going to be running through here. So if I'm not sure if I've put this in the chat yet. I'll put this in the chat for anybody who wants to follow along. This is Jim's tutorial here, and this is what we're going to be working through. So as it says here, it's a minimalist tool for interacting with the Wallaby testnet. So Wallaby is one of the testnets that we use at Filecoin. So it's a public testnet that we're deploying FEVM on. It gets periodically reset, but it allows us to test this stuff out without having to actually deploy locally. So we need to have Node.js installed on a system, and I've got Node.js here. So just double check. Yeah, I've got Node.js here, and we need to install this package here that Jim has created. So go ahead and do that. Just paste that in, and that will install that. So that's installed now, which is good. Now, depending upon what dependencies you might need, it might take a little bit longer to install that there. But there we go. So that's it. And there's some details here of the usage of the tool, and it shows what commands are available there. But we'll get onto that in a bit. So there's some other bits and pieces we need to do. So we're going to compile a Solidity smart contract. So one of the things we're going to need is a Solidity compiler. So it says here we need a Solidity compiler, and there's some instructions here. So if we go and have a look at that, there's instructions for various different platforms. I'm going to scroll right the way down to macOS because that's what I'm running here, and I'm using Homebrew. So Homebrew is a package management tool. If you've done any development, you're probably familiar with it, and so we're going to use that to. So I'm just going to run through here. So brew update. I'm already updated, so it should be pretty quick here. So yep, brew upgrade, just to make sure everything's updated. And so there we go. And again, that should be pretty quick for me. Yeah, that might take longer for you because you might have stuff that needs updating. And we need this Ethereum cask here. And then we need to install Solidity. And that'll give us a Solidity compiler. And that. And install. And again, like I said, it might take a while depending upon what dependencies you need. But there we go. So if I oh, I didn't mean to quit. I meant to clear the screen. Oh well, we've got a clean screen cleared here. If I do Sol C, we've got the Solidity compiler there. So that's good. That's what we needed. I'll shut down that other tab. There we go. So let's go back to our instructions here. So we've got Solidity compiler installed here. So we're going to need a directory, and we're going to create a very simple storage Solidity contract here. So I'm just going to create sol. I'm going to go into there, and I'm going to paste in to this. What did we call it? What was it called? Simple storage sol. Simple storage sol. And I'm going to paste this in here. That's it. So we've got that there. So that's our very simple function. And what it does is it's got a get and a set. So all we can see here is a set function here, and that set function sets this stored data variable to what we pass in, x, and we've got a get function that gets it. So it's just a very simple way of storing and retrieving a variable here. So that's our smart contract. So now what we need to do is compile it. Now, all of these things so far that we're doing are the same pretty much regardless of which blockchain you'd be using, right? So what we're going to do here is I'm going to copy this. and paste it in. Actually, if I just clear and paste it in there. So solc --bin --hashes. That's going to give us a binary. It's also going to give us what's called the hashes of the functions, and you'll see why you need that in a little bit. We pass in simple storage.sol, and we've got our output directory there, output. And it says it's going to be compiled, and there's a directory called output. So if we look here, we've got this directory output. If I go into there and have a look, we'll see our simple storage.bin. That's the binary file that's been compiled, and this simple storage.signatures. There we go, signatures. And that gives us the signatures, hashes of the two functions get and set. And we'll need those in a bit in order to call the functions. So let's go back here to our tutorial. So we need to set up a wallet, right? So Glyph is a wallet for Filecoin. So I'm going to go here to Glyph wallet, and I'm going to go down to what's called burner wallet. So because we're doing development here, I'm just going to create a wallet here. This is a test net, and I'm just going to create a wallet here, right? So again, caveat, you wouldn't ever do this in production. You wouldn't ever be live streaming your secret phrases to everybody over the internet. But here we go. So I'm going to copy those, and I'm going to put them in here. I'm going to put them in a file. Actually, I think it gave me an example as to where I should put them. Let me just double check here. A file called don'tlookhere.txt is what they've just suggested. So I'm going to do that. So I'm going to do that. Cat to don't look here.txt and put our entries in there, right? Now it's asking for some to ensure we've got it here. So what's the 7th word here after salute? So if we go back here, vocal. And the 9th one, which is after owner, is review. And the 19th one after virtual is giraffe. And it's asking for the last one, the 24th, which is the checksum, which is entry. And there we go. Next, and hit next to access the wallet. So there we go. That's going to set our wallet up. And again, this is just a testnet. This is a demo wallet on our testnet here. And you can see we've got 0 fill. We've got no Filecoin. Now, in order to deploy a contract, we're going to need to be able to pay for it. We're going to need to be able to pay the gas fee on the network. So we're going to need some funds. And again, going back to Jim's tutorial, he's got us here. So it says here we can create. Oh, we need to create a .env file. We'll do that. So let's do that. So this is a file that's just going to tell the tool where it can find our seed phrase, right? So again, I'm just going to .env. I'm going to put that in there, right? And that just says the seed phrase is contained in the file don'tlookhere.txt. So that way, Jim's tool is going to know where to find it, right? So there we go. And we need to fund the wallet from the faucet, right? So a faucet is a tool that can give you some free currency. And in this case, it's the current Filecoin currency you fill. And this is a test net, so it's not really worth anything, but there's a tool here that allows us to do that. So we can go to the Wallaby testnet faucet. So if I go there, and if I scroll down, I need to put the address in. So if I go back to my wallet, I should be able to copy the address. There we go. Copy the address from there. Paste it into here. I am a human, I believe. Image of fish jumping over the water. Wow, these are quite specific. The last one I had asked me for adult cats and presented me a whole load of cats and a whole load of kittens. And I have to say, it took me a little while looking at them as to identifying which were cats exactly and which were kittens. So if I hit send, there we go. That should be sending. It's not said anything there. I think that should be doing it. Let's go back to our wallet. Transaction history. Here we go. We can see pending incoming transaction 5,000 fill. So that's coming in as a pending transaction. So we've just got to wait for a few blocks to go by for that to arrive. So let's go back and look at Jim's tutorial here. So just for anybody who's catching up here, we're deploying a simple Solidity smart contract on the Filecoin FEVM, the Filecoin Ethereum Virtual Machine. Now, this is a Ethereum Virtual Machine that's in development at the moment, but this is just to kind of show you what is possible at the moment as we're developing it, right? So we've got this tutorial here from my colleague Jim Pick, and what we've done is we've installed his little tool here, and we've created a simple storage Solidity contract that just has two functions, a set and a get. When you call set, it stores a number. When you call get, it retrieves that number back. We installed a Solidity compiler from Homebrew on macOS there, and then we've just run this command to compile it. We've then gone to set up our wallet. So we've created what's called a burner wallet. That's just a wallet on the testnet, and we've stored our seed phrase, and we've then used the faucet to send us some funds so we can pay for the gas for the transaction. So if we go and have another look back at our wallet, yes, that's completed now. So you can see we've got 5,000 Filecoin tokens, 5,000 filled in our wallet. So we've got some funds to be able to pay for the deployment. So now what we've got to do is we've got to create a Filecoin actor, right? So we've compiled our smart contract, our Solidity smart contract. Now we've got to actually deploy it to the network and create what's called an actor, which is the Filecoin term for a smart contract. So this is where Jim's tool comes in. So we've got it here, and we call this create actor command here, and we pass in our simple storage.bin. So let's do that. So just down a directory and run it from here. So there we go. Let's run that. No seed phrase found. Oh, I had my .env file in that directory. So let's move it down here instead. Right, let's try that again. If I just clear the, run that again. Handling error. Don't look here. Oh, we got our don't look here as well in the wrong place. Yep, that needs to be here as well. So, right, let's try one more time. Third time lucky. Here we go. Right. So that is actually sending the message to the RPC endpoint, to the Glyph gateway, and it's waiting for it to appear on the chain. So I can actually look back here, and I can look at our wallet. We can see there's a pending transaction here, and that is a pending transaction that is deploying this smart contract to the network. So we just got to wait a little bit while that goes on. Any questions so far from anyone in the chat? If anybody has any questions, then let me know, because this might take a little while just while we wait for it to go through. Let's just go back and have another look here. That's still going on there, still pending. And then once we've done that, the next step, we're going to actually be able to invoke these methods on our smart contract, right? So we're just waiting for that to go through. So again, just to recap, we're using this tutorial here from Jim Pick, and we've compiled a smart contract using the standard Solidity compiler, and we have set up our wallet using what's called Glyph wallet as a burner wallet, and we have got some funds from the faucet. We've created our Filecoin actor. Well, that's what we're just waiting to complete here. So see here. That's finished. Right. So it tells us the gas used. It gives us the ID. So we're going to need that. And we should be able to see actually that this is completed. If we look at Glyph wallet, yeah, that's completed there. So we can now actually call our function, right? So if we go back here, it shows us how we can do that. So remember that file, the signatures file? That gives us the signatures of the methods that we compiled, and we're going to need those in order to invoke the method. Now, soon we're going to be able to invoke it by name, but for the moment we need to invoke it by signature. So what we need is this Wallaby FEVM signer. We're going to call this invoke actor. So I'm going to put that there. And then we need the ID of our smart contract. And that came up here. So you see this T. This is going to be different for everybody because it's depends upon, when your contract was deployed. So it's going to be different for everyone. And then the method from our signature here, right? And I don't have these up on the screen. Oops, right. Let me just abort that a second. And in our output, we have simple storage.signatures. So that's the signature there. So let's try that again. So we need that. So we're going to need the signature. So we're going to call set. And we're going to have a number here. And we're going to store that number. And it's in hex. If anybody's in the chat and wants to come up with a number, I'll store that. But for now, I'm just going to go A, B, C, D, and we'll store that. Well, actually, let's just do it slightly different from at least the tutorial, just to show that it's not doing exactly the same as the tutorial. I'll go A, B, C, F and store that. And so that's going to invoke that on the gateway. So that submitted it, and now we wait for it on the chain again. So if we go back here, we should see again that it's in pending. And we just wait for that to appear on the chain. Soon you're going to be able to use standard Ethereum tools, things like Hard Hat and that to deploy. And you won't need Jim's little tool here. But this allows us to deploy them at the moment until the RPC endpoints are at such a point where we can use the standard tooling. But the idea being soon you'll be able to use the standard tooling. You'll be able to use things like MetaMask. You'll be able to use Hard Hat, all the tools that people use within the Ethereum ecosystem. You'll be able to use directly on the Filecoin Virtual Machine. Now, at the moment, like I said, we're still under development here. And you can see this incremental delivery plan. There's certain bits and pieces that are coming up. So at the moment, we don't have this full Ethereum JSON RPC. Well, we do have, but we don't have, I think, some of the other bits that are needed to be able to use Hard Hat quite yet. And there's basically the account creation stuff I don't think is there. So that's what's sort of missing for that. But yes, we've got a bunch more releases that will be coming up. Like I said, roughly once a week. And then by the time we get to the end here, we should have all of that in place. Right, so that's finished. No value returns. That's because we were doing a set, right? So there's not going to be anything that's going to come back from that. So the next thing we want to do is we want to do a get. So we want to invoke actor, and we can delete all of this here. And the method signature that we want, so it's still the same actor, still that same T01016, but we want to call get. So I'm going to copy that signature there. That tells us we want to call the get method. And that's, again, executing on the network. And we'll wait for that to come back. We should be able to see that on our wallet. Yeah, that's now pending. There. And we should see that soon come back. And what we should get back from that will be the value that we set in that first transaction. Wait for that. Like I said, in the meantime, you can go to fevm.filecoin.io to find out more. We're working on more documentation that will be coming soon for all of this as well. And there's a couple of events coming up. Probably the next main event is an event called Phil Lisbon, which is at the end of October, start of November in Lisbon. And you'll be able to find out a lot more about Filecoin Virtual Machine. Suspense, says Jim. Indeed, suspense. We've got fingers crossed here. Ta-da! It worked. Thank you, Jim. It worked. ABCF. So that's the value that we stored. So we've done it. We have submitted a transaction. So we called the set. That value has been stored on chain on the Filecoin network, on the Filecoin blockchain. and we've called get, and we've got that back again, right? So that's, like I said, it's a very simple smart contract, but it demonstrates kind of the initial where we are at the moment with the Filecoin Virtual Machine and FEVM, and the fact that we can actually take a Solidity, compiled Solidity contract, deploy it to the Filecoin network, and actually execute it, which is fantastic. So, you know, the work coming up in the next iterations will be to expand the number of opcodes that it understands, because at the moment it's slightly limited in what it can understand of Solidity. Hence, we did a very simple contract to start with. And there's a lot of things around kind of accounting for gas and some other bits and pieces that are coming up. But anyway, I hope you found that useful. And thanks. Well, thank you, Jim, for creating this tool. And thanks to all the developers working on FEVM and FEM and Filecoin in general for enabling this. So, yeah, I hope everybody found that useful. And, yeah, if you have any questions, then feel free. Actually, you can reach out to me, probably the easiest way. Well, you can actually, there's two things you can do. You can either get onto the Filecoin Slack channel, and there's a FEM entry, an FEM channel there. And so you can actually go through there, or there's also a Discord channel. But if you click on this chat with developers on fem.filecoin.io, it'll bring you up to a redirect that'll take you to Slack. I'm already logged in there, so I'm not going to go through that. But there we go. You can come and chat with developers and find out more. So thank you very much. And yeah, if you found this useful, let me know, and I will do another one. You can reach me on Twitter, twitter.com/Amato. So you can get me there. And there is also an FEM FEM dev as well, Twitter account, which has a lot of stuff there if you want to follow what's going on with the Filecoin Virtual Machine development. Okay, so thanks very much, and I'll see you around again.